Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 23, 2025, about 4 days ago. The big hook is a unified method that treats a reference video as the prompt, and it reaches a 38.7% user preference rate that rivals condition-specific commercial systems. The paper is titled Video as Prompt, Unified Semantic Control for Video Generation, and as we will see later, the results are surprisingly strong across varied controls. In short, this paper introduces a plug-and-play mixture of transformers guiding a frozen video diffusion transformer with a temporally biased position embedding, plus a new dataset of over 100,000 paired videos spanning 100 semantic conditions for robust, zero-shot control. Also, the authors shared the official GitHub repo. You'll find ready-to-run inference pipelines built on diffusers, 2 model variants with downloadable checkpoints, a minimal demo script, benchmark runners, and full training recipes including multi-node SFT and DPO. There's a requirements file, env script, example assets, and links to the VAP-Data dataset. Find VAP1 2.1 14 billion plus 5 billion VAP and COG video X 5 billion plus 5 billion VAP with diffusers image to video demos, install steps, and minimal Python examples. Alright, Figure 1 illustrates the core idea. A reference video acts as the prompt, so the generator adopts its high-level semantics without pixel matching. Semantic control means guiding by meaning, like concept, style, motion, or camera, rather than copying frames. The top row shows concept guidance, where the output inherits a character or transformation. The bottom row highlights zero-shot control, which handles an unseen instruction and still preserves temporal consistency. So, Figure 2 contrasts control strategies and makes the pitch for video as prompt. The left panels assume pixel-aligned inputs which push residual signals into the diffusion transformer and risk artifacts. The middle panels fine-tune per condition or bolt on task-specific modules so they do not generalize. The right panel shows in-context control, where a reference video guides a frozen backbone through a parallel expert so the model keeps prior knowledge. This design targets semantic alignment without forcing any frame-by-frame mapping. So, Figure 4 shows how a reference video plus captions act as the prompt, guiding a frozen video diffusion transformer through a parallel expert for unified and context control. The left block depicts the trainable expert transformer that shares full attention with the frozen backbone, so prior knowledge remains stable. The middle panel walks through tokenization and mixture of transformers blocks before decoding. The right diagram illustrates temporally biased rotary position embeddings, which shift reference tokens earlier in time to avoid false pixel alignment. Alright, Table 1 summarizes how the unified method stacks up on text alignment, motion smoothness, dynamic degree, aesthetic quality, semantic alignment, and user preference. Dynamic degree means the measured amount of meaningful motion, so higher values indicate livelier videos without jitter. The bottom row shows video as prompt leading open source baselines and nearing commercial systems, with about 39% preference. It also posts a strong clip score and the highest motion smoothness, which signals stable, coherent movement. Wrapping up, 2 takeaways stand out. Treating a reference video as the prompt with a plug-and-play mixture of transformers enables unified, zero-shot semantic control, and the temporally biased position embedding keeps guidance robust without pixel mapping. Results approach commercial quality at about 39% preference, pointing to practical, general-purpose video control. That is it for the AI Research Roundup. I am Alex. Thanks for listening.